Today we're going to learn about equations of parallel and perpendicular lines. Parallel lines have equal slopes, which means if one line has a slope of 4, then a line parallel to it must also have a slope of 4. Whereas perpendicular lines have opposite reciprocal slopes. So if the slope was 3, the perpendicular slope would be negative 1/3. As well, if the slope was, let's say, negative 1/2, the perpendicular slope would be positive 2. You change the sign, that's the opposite, and you flip it, that's the reciprocal. Find the slope of each line. Here, we remember y equals mx plus b, where b represents the slope. So, m equals negative 1/2. That's our slope. It's just that easy. Now here, notice that it's not in slope-intercept form. So we're going to have to manipulate the equation. There's also another little shortcut I might teach you guys later. Anyway, we're going to divide both sides by -5. And already we can see that the slope is 2/5. So that's it. 2/5. For this example, we still want to find the slope. So we're going to look at rise over run, up 2, but back 3. So up is positive, back is negative. So the slope is negative 2/3. I like to put my slope, I like to put the negative sign out front. Okay, example 2. Let's write the equation of the line through the point -8, -1, and parallel to this line. So the first thing I like to do is say if it's parallel, then it has the same slope, and I also have a xy, so that's going to make this very easy, -8, -1. So now I can use y equals mx plus b. There's also a point slope form that I'll show you as well. But for today, we'll just stick with slope-intercept. And I'm just plugging in the slope and the xy that I know, just like we did in the last lesson. So that's -2 plus b. Add 2 to both sides. 1 is our b. So now that we know b is 1 and m is a 4th, we can simply write 1/4 x plus 1. Final answer on that. For example 3, write the equation of the line through 3, 4, and perpendicular to this line. Well, already I see my x and y, and my slope, since it says perpendicular, I need that to be -3/2. I changed the sign and I flipped the fraction. So, using y equals mx plus b, I'm going to plug 4 in for y, -3/2 in for my slope and 3n for x, and I'm going to solve for b. So 4 equals, remember when you multiply fractions, you multiply numerator with numerator and denominator with denominator. Now I'm going to get b by itself. So I'm going to add 9/2 to both sides. But we have a small issue here. We don't have common denominators. So I need to multiply by 1 always. So that's going to make this 8/2. Remember, you can multiply by 1 without changing the value. So that's 8/2. And now I'm going to add the 8/2 and the 9/2 and get 17/2. Now I have my slope and my y-intercept. So slope is -3/2. Don't forget to write the x and my new y-intercept. That was a lot, so let's make sure everyone's clear on that problem. This asks for the line perpendicular, so we changed the sign and we flipped the fraction. Then we took our x and y and plugged it in with the new slope. We solved for b. Then we took our new b, plugged it here, and our new slope right here. Now, for our last example, write the equation of the line through the point and perpendicular to the line. This time, I didn't tell you the equation of the line. So, we still need to figure out what the slope is. So we can count the rise is 3 and the run is 2. So rise over run gives us a slope. This line has a slope of 3/2. So the perpendicular slope would have to be -2/3. So this is the slope that I need to use for my line. And I'm going to use this x and y. So y equals mx plus b. And I can plug all my values in. The slope is -2/3. X is 3. And solve for b. Oh, we got lucky this time. And I'm going to add 2 to both sides. B equals 3. And so now my new equation takes this slope, boop, with the new y-intercept. Let's graph it and see if they appear to be perpendicular. So, starting at 3 on the y-axis, down to run 3, and we knew that we were supposed to go through that point, so that shouldn't surprise you at all. And it looks like a 90-degree angle to me. That concludes this lesson.